Hello, welcome to this informative session on the configuration components required for SD-WAN. What you see before you in this visual are the configuration steps that are required to get SD-WAN up and functional. I like to break them down into 5 steps. Step 1, it all starts with a tag. That tag is assigned to an SD-WAN interface profile. In turn, that SD-WAN interface profile is associated with the physical interface. Step 1. Step 2, we said it was all about the tags. Those tags, in turn, are also applied to a traffic distribution profile. We can configure that traffic distribution profile in a few different ways: best available, top-down, or weighted session distribution. The manner in which we distribute the traffic is dictated by the path quality profile. Step 3, the path quality profile. In the path quality profile, we specify certain metrics, those being latency, jitter, and packet loss thresholds, to determine if a path is qualified or unqualified. Qualified, meaning that a metric has not been exceeded, or unqualified, meaning that a metric has been exceeded and I need to fail over to another path. Step 4, we pull it all together in the SD-WAN policy. In the SD-WAN policy, we specify the application that we are interested in for the purposes of SD-WAN optimization and associate that path quality profile and that traffic distribution profile with that SD-WAN policy so that we know how to treat that application when it comes to intelligent path selection. In step 5, enabling SD-WAN on the physical interface. And that SD-WAN physical interface, once pushed to the device, is associated with an SD-WAN VIF. It can either be a VPN VIF or a DIA VIF. Now, let's take a closer look at Panorama to see this a bit more in depth. As mentioned, it all starts with the tags. Here I have 3 tags: low-cost ISP1, low-cost ISP2, and MPLS. I have taken those tags and associated those tags with an SD-WAN interface profile. You can see those tags right here: low-cost ISP1, low-cost ISP2, and MPLS. They've each been associated with an individual SD-WAN interface profile. In turn, that SD-WAN interface profile, which contains those tags, has been associated with the physical interface, as you can see here on Ethernet 1.1, 1.3, and 1.4. That is step 1. And if I go into one of the interfaces, you can see I've taken that SD-WAN interface profile and associated it with the physical interface. Step 1. Step 2, what did we say? It all begins with the tags. We have those tags. Those same tags are associated with a traffic distribution profile. We can have multiple traffic distribution profiles which dictate how we want to distribute traffic for a given application. For this one, we're using the traffic distribution profile of top-down priority, which means for my links, low-cost ISP1, low-cost ISP2, and MPLS, that I'm preferring them in a top-down fashion as listed in a primary, secondary, and tertiary manner for the purposes of traffic distribution. How do I know how to distribute the traffic? Well, that depends on whether the path is qualified or not qualified. And what dictates that? Step 3, the path quality profile. Let's take the iPerf application. I've configured a path quality profile for iPerf, and I have assigned these given thresholds that you see before you. Now, you can see here that the sensitivity level for latency has been changed to high. By default, the sensitivity for all of the fields are set to medium. If left at medium, the order of evaluation is packet loss first, latency second, and then jitter. Essentially, what I've done by specifying a high sensitivity level for latency is I'm giving preferential treatment to latency. I want that to be evaluated first before any other field. So for wherever I assign this path quality profile, the first thing that I will look at is latency. And if that threshold has been exceeded, now I need to find a better performing path. Step 4, we pull it all together in an SD-WAN policy. So let's take that iPerf example. I have iPerf here. I've specified that for the purposes of the decoder. Want the decoders to be looking out for iPerf. Once I identify that traffic, well, guess what? I have associated that path quality profile. Here it is, iPerf PQP. That's the same one that we just saw with the 80 milliseconds of latency. Therefore, as long as the path is qualified and I have not exceeded that, well, I'm going to distribute traffic as annotated in the traffic distribution profile. And I have taken that traffic distribution profile and associated it right here. Now, when that path is no longer qualified, I can make intelligent path selection decisions based on this path quality profile and move the traffic to a better performing path that is qualified and less than the metrics that are specified in the path quality profile. And finally, step 5, on the physical interface, we enable SD-WAN. Here, SD-WAN is enabled. We configure our VPN overlay, our devices, our VPN cluster. We push to the devices, and these physical interfaces are associated with an SD-WAN virtual interface, either a DIA or VPN VIF. The DIA for local internet breakout, and the VPN VIF for traffic that is going to traverse your SD-WAN overlay infrastructure.